let's go ahead and prove that lemma. So let me just restate it again, because I know you want to know why that's true. And I'll just kind of sketch it out, though, for you, just to give you an idea. So the idea is for all x and y positive real numbers, that you have that x times y is less than or equal to x to the p over p plus y to the q over q. If 1 over p plus 1 over q equals 1, and p and q are in the interval from 1 to infinity, inclusive, really. Okay, so the idea of proof is this. Well, look at this function of two variables where you take this side minus that side. So it'd be x to the p over p plus y to the q over q minus xy. And restrict f to this area, right? The first quadrant. And so we want to, let's find the maximum. Let's see, is that what we want, or the minimum? We want the minimum. Or actually, what will actually happen is the minima of the function. And as is true, which from vector calculus, what we want to do is take the gradient and set it equal to 0 for any interior minima, and then we have to see what its end behavior as you get away from, go towards the boundary, what happens. And so let's just examine the gradient. So gradient of f is going to be the x partial derivative, which would be, notice the p's cancel, so you get x to the p minus 1, and then minus y, and then the y derivative would be, the q's cancel, so it'd be y to the q minus 1 minus x. Okay, so we have, so for a critical point, this equals 0. So y equals x to the p minus 1, and let's see, x equals y to the q minus 1. Now, it turns out that if the first equation is satisfied, because the way the p and the q are, the second equation is also satisfied. Yeah, so you get that y to the q minus 1 is x to the p minus 1 times q minus 1. And let's see, since let's solve for q in terms of p in the equation. 1 over p plus 1 over q equals 1. So let's see, subtract the 1 over p, you get 1 over q equals 1 minus 1 over p, which is p minus 1 over p. And so that gives you that q is equal to p over p minus 1. So, yep. So this is p over p minus 1. So then q minus 1 is equal to p over p minus 1 minus p minus 1 over p minus 1 equals 1 over p minus 1. So notice this equals x. So this, right, because it would be x to the 1. If I take q minus 1, put that in there, I get just x to the 1. So the second equation is automatically satisfied from the first equation. So that tells you that gradient of f equals 0 whenever y equals x to the p minus 1. So I'm going to kind of draw a graph. P is greater than or equal to 1. And in fact, let's take greater than 1 just to make it simple. then it's going to look like this or like this. I'll just kind of, like for instance, if p equals 3, it's probably going this way. If p equals 3/2, it's a square root, so it just depends. And so the gradient equals 0 there on that line. And then if you actually plug in points here, when you're away from this, so points over here, y is greater than p minus 1. So the first component is negative. And then the second component, that's the same thing as, right. It turns out the second component is then positive. So it turns out that the gradient's 0 here, and then if you check other points, it's always moving away. So so whatever the value of the function is along this curve, if you move away from the curve, the function goes up. So the minimum is achieved on this curve. So actually, let's just see what that value is. So if we plug in y equals x to the p minus 1, we get that, let's see, x to the p over p plus x to the p minus 1 times q over q minus x times x to the p minus 1. All right, so simplified, you get x to the p over p plus x to the, okay, q is p over p minus 1, so that's x to the p over q, right, from that. Okay, p minus 1 times q is p. And then minus x to the p, and so it's 1 over p plus 1 over q minus 1 times x to the p, which is 0. So, in fact, and this is a global min by looking at the gradient. And so, therefore, f of xy is greater than or equal to 0. Always, because it achieves its global minimum on that curve. And that's exactly what we wanted from the lemma, is that this minus that is greater than or equal to 0. So that's it.